Tactical flow meter.
Once you start the program, you can choose between validation test procedure or view, edit, calibration curves. These are instructions, video instructions. One of them you're watching. View, edit, calibration curve. I'm going to click this. I will find them. I'm going to use COM9. That's what's in the config file. It's going to check and see what the difference between the time in the machine and time on the computer. They're the same. I'll set them anyway. It doesn't take that long to do it. The next thing it presents you is it's reading. It's going to write a safe version of the coefficients in your machine. This is in the meter. This is what's in the file. It's now going to confirm whether or not the factory values are equal to those in your meter. If they're not, there's an easy way to fix it. This is reading all the factory values, and now it's reading those values in the meters, and if all these are green, it's fine. So you get to, it turns itself off, and now it's filling out all the data. This is the traffic for the float. This is the traffic for the integer 32. This is the address. This is the COM port it's on, and you can't change any of these until do some little tricks further on in setup. But this is for the purpose of this, you click reread and you can read all the data in your meter. So I'm going to pause while that's doing the same thing again. Here's the second one. Here's results of that. Also, the traffic down here shows you what it's reading at the time. Goes away after 3 seconds, and now it's going to repopulate all the data. All of this data is the data that allows you to see what was done at the factory at 10 through 100% at every 10%. And in case you need to change your flow, let's say you know that where this, grab this thing with the cursor, with this part, and you can move this around and it shows you what the ticks are and the flow. So the flow is 24 and the ticks are 21781. Let's say that you know that at this condition of 21781 the flow is really 26. See how you can edit the curve, and you can modify your calibration data, and you can, given enough correct data, go and get everything the way it needs to be. So that's what these are. And there's no harm in playing with these while it's running. The purpose of this is this one allows you to adjust the full scale of the 20 milliamps, the 4 milliamp 0, the 0 to 5, and the 0 volts. That is also validated in the validation one. But should you discover that the meter doesn't agree with your devices, you could click this. The 4 to 20 milliamps is now 3820 for the DAC. Click Start. And now you'll measure your DVM and adjust this so that it says 20 milliamps. So right now it's 19.988, 9999. I mean, that's as close as you can get. So it wrote 3823, and you see the last thing it wrote here. Click Stop, and that's the new DAC value. These is for the purpose of setting a flow controller. Allows you to set the I and P terms, and you can set the flow and set the set point. If you don't have a flow controller, this is of no use to you. If you want to simulate the flow and to validate the analog outputs, click Start Substitution. And in this one, you click Drive. And when you mess with this, the flow meter will be reading according to these tick values. So as a matter of curiosity, we could look, if we copy this tick value, Control C, I'll put it here, Control V, 24340, 24340 corresponds to 30, so it should say 30, 24340, 30.4. And as I change it, be within the specs of the meter. When you hit OK, it turns off the substitution. You'll notice your meter will go back to 0. And so that's the purpose of that one. Terminal allows you to read any one of the variables, should you want them. If I want to know the version number, click the version number, and it shows up here. If I want to know what the Modbus address is, I need to change it to some other number. I would click write and write the value to 2. Write and read the Modbus, just plain old read, and we see that now it's 2. I'm going to put it back to 48 because I use it. Modbus write 48, 48, write. Okay, Modbus. This is a Modbus RTU. If you have you look at your device manager, this one is COM10. The Flowmeter has some Bluetooth on there. COM10. Update the Modbus address. 202 should get 12345 on an I32. 12345 and 204. Or let's look at 200 and read 200 and see what we get our 1, 2, 3, 4. See, here's the float. For this is so you can determine whether you're ABCD. This is all some utilities for you to determine how to read. The reason you use these commands, if you want to make sure your device is working, read 200 to get 1, 2, 3, 4 here, a float, then you know that the meter's working. And we're starting at byte reg 200, 4 bytes, and we're de-encrypting it, if you will, using CDBA. Read the Modbus byte order of the device is DCBA. And the commands, here are a number of commands. You can go scroll through. Real-time display for the purpose of, so you could reset the totalizer. Right now the totalizer is here. Click reset. And here is the element of the, it's 2 to the 5th element, and whether there's any zero suppression. So that is the only way to get out of that is to click stop. Totalizer, if you need to set up your data, your external Omron, the units of measure are minutes. The decimal point can be any one of these. Normally it's 1. And you can run a substitution and look at your totalizer here and compare it to your Omron totalizer. So what you do is you do this, reset the totalizer to 0, push your reset button on your Omron or whatever it happens to be, turn the substitute on, and then you'll see your totalizer on the OLED agree with this number by a little bit. And then you'll want to see that your totalizer on your Omron agrees, and if you're reading, you're going to be reading these digits, so it'll be 5 or 6. If you want to read more digits, stop, turn it off, so the meter's live, go to 0.1, and we'll see we need maximum of 10 pulses per second. Reset totalizer, reset the Omron. When they're both reset, click this to substitute, cycle substitute on, and now what it'll do, it'll be reading 2 digits. So this will be saying 22, 23, 32 on the totalizer, on the Omron totalizer. So that's what these are for. This must agree with the units in your meter. The last letter is M, means minutes, standard cubic feet per minute. I'm going to turn off the substitute so the meter's real. Now I'm going to show the method of reading a data log. Push this button, and the data log You say no, do not initialize the COM port. This one has 3 logs, and log 1 has 1 event. Log 1 event. Log 2 has 27 events. Log 3 has 414. The instructions for the data log are here, so I'll invite you to click that, but show you real quick viewing the data log. So now I can totalize flow is a good thing to look at, and I've shown in the other ones. Here's the version, serial number, start date, start time, and then you have the seconds, which goes 0, 5, 10, 15, 20, 25. So that's the totalizer, and when you can save it as shown in the video here. Watch that and exit to get back. Next thing is looking at the factory. To read the factory, should you have an interest in making sure everything's still happy with your meter, click this button and you've seen this screen before. So this is going to read the factory values, and then this one is going to read what's in the meter, and these should agree. You can also read a file. So I'm going to go read a file that I just made today, or let's say this file, and read that one. And that's what the file is. I'll pause while it's reading it. Remember, I adjusted the current span. It shows that that was done. Next thing is you can write the data from the file to the meter, and you'd select the file that you want to put in there. So let's go to grab the file when I started at date modify 3. And you can see how easy these files, 3896. So I'm going to select that one, and I'm going to write that data from file to the meter. It's going to put that 3896 back in the meter, so it's the way it was when I worked on it. And now they both agree. You can recover factory defaults here. Issuing this command will restore the configuration. Click OK. Wait 5 seconds to ensure all is written. And now it's going to read the factory data and put it back into the meter. All done. Now we're going to read it because it verifies whether it's done. So I'll pause while that's being done. In the meter, soon the factory stored values will come up. So they agree. Read what is in the meter or manually update the meter and save to disk. The purpose of this is if you want to edit data, watch when the data comes up here, which I wouldn't recommend folks doing this, but you could go change that 3896 manually yourself. Write data to meter, or you can abort. There are some things you can't change. You can't change the version and serial number, and you can change all these other things and really mess the meter up, but you have a method of getting it back. Abort and do not save or write. Just gonna get out and let it finish its thing, and that is it. The setup tab, should you need to work on some very magical things, you would make a telephone call and you'd want to learn what this magical password is. So I'm going to write a wrong password, and it's not going to write enable anything. The instructions are shown here. These are the commands. /R means a carriage return in computer shortcut. If your USB dies, click this. It's not going to kill anything.